Alright, so in this module we put our knowledge of systems to test and plug them into these word problems here. For example, the first one, a few families took a trip to a park together and the tickets cost $6 each for adults. So that means, for example, this might seem a little obvious, but bear with me here. If one adult goes, right, and each adult costs $6, that means you have one adult, the number of adults, times the cost in dollars, and that's your cost for adults, which would be 6. If you had two adults, right, what would happen? You do 2 times $6, which should give you 12, and so forth, right? So you have the number of adults, let's call that A, times the dollar amount, here is 6, equals the total cost, which is 6A. In other words, it's the price times A, the number of adults. And here, with the kids, it's $3.50 for each kid, so that has kind of the same logic there. So we think of adults as $6, the cost of an adult, times the number of adults. And then we think of kids as $3.50 times the number of kids. Let's call that K. And we know the group paid $36.50. So if we add up how much each cost, right, however many kids and adults went, the total cost is $36.50. So what we have done then is identify our first equation. $6 times the number of adults plus $3.50 times the number of kids gives us the total cost of $36.50. Then they have to do this. They have to give us a second statement. And sometimes you'll have to hunt for it. But you need a second relationship to solve for two variables. The idea is that with two variables, you need two relationships. There were 5 fewer adults than kids. So if there are 10 kids, for example, then there are 5 fewer adults. That would mean there are 10 kids, right? Number of kids minus 5 gives you the 5 adults. So we take the amount of kids, K, subtract it by 5, and that gives us the adults, A. So we have these two equations, and now we can use substitution. I'm going to use substitution because you already know that A equals K minus 5. So in the second equation, 6A, instead of writing that, I'll write 6 times K minus 5 plus 3.5K equals 36.50. So we get 6K minus 30, 6 times 5 is 30, plus 3.5K equals 36.50. And I'm going to clear some of this off. Okay. So here we have 6K and 3.5K, that's 9.5K minus 30 equals 36.50. And I found with a lot of these modules, we don't even need a calculator. The numbers don't look friendly, right? When we add 30 to both sides, we get 9.5K equals 66.50. I found a lot of times the numbers divide quite nicely. I mean here, 9 goes into 63 7 times, and that's pretty close. We have 9.5 times 66. It's a first good guess, and it works. 9 times 7 is 63, and a half of 7 is 3.5. That makes 66.50. So that means 66.50 divided by 9.5 is just 7. That means 7 kids went on this trip. And remember, the adults, right, equal the number of kids minus 5. So kids are 7 minus 5 is 2. So the adults equals 2. And you can plug this in to see that it works. There are 5 less adults than kids. That works. There are 2 adults, 7 kids. Plug it into your original equation, the 6K, right, plus 3.5, sorry, 6A, 6 adults, plus 3.5 K, excuse me, equals 36.50, and you'll see that this will work as well. It's a really good idea to plug it into both. Then you get equations like this, which can be solved by pretty intuitive guessing. Though it's a good practice to develop your algebra skills here. The sum of two numbers is 35. So x plus y does equal 35. And the difference is 1. So x minus y equals 1. What are the two numbers? Well, here I might use elimination. If I add these two up, I get 2x, and the y's cancel out. So I get 2x equals 36. And then if that's true, I can divide both sides by 2, and x equals 18. Then I take the x value and plug it back in somewhere. I know x plus y equals 35. right? And if x is 18, 18 plus y equals 35, and that means y equals 35 minus 18, which of course, right up here, so ran out of room, y equals 35 minus 18. 35 minus 10 is 25, minus 8 is 17. So y is 17, and x is 18. So in these kind of problems, you really want to set up two equations to solve for both variables. And there will be other variations of that in this module. Thanks.